Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to create an endless runner inside of Godot using C#. So in this tutorial, we're going to run through the basics of how to build an endless runner. So how to get objects to spawn, how to get them to come towards you, how to limit your character to just a few lanes. In this case, it's 3. And how to properly handle score, how to build a leaderboard, and how to save and load your game. So we're gonna have a full game loop. So this is an entire game package that you can start from, build your own game. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing that we need to do is we need to actually build out our player and our environment. So what we'll do is first we'll come into our 3D scene here. We're going to right click, add a child node, and we will add in a CSG mesh. And that's going to be a cube mesh like this. I'll bring it in a box and I'll come over to our mesh here and I'm gonna make it 10.5 and something large like 200. That's going to give us a really large runway for our game. Now we can come in here and make sure that our scale is set to 1 just because I might have changed something here really quick. Okay, so that's good. And then we'll kind of drag this guy forward so that way we have some additional space. Now, the way that the game is going to work is our player is going to stand still and the world's going to come at our player. Because it's an endless runner, the world actually comes to you and you just kind of move left to right and that's it. So it'll be pretty easy to build this out. So what we'll do is we'll right click, add in a child node. We're going to add in a character body 3D. We're going to right click, add in another child node, add in a collision shape, and let's add in a mesh instance as well. Now you could make this into something like a CSG mesh and give it collision, and that technically would work as well. Now I'm going to come in here, I'm going to go in here, add a new mesh and make it a capsule mesh. We'll zoom in like so, and I'll drag this guy up something like that. And I'll click on my collision shape and I'm going to add in a capsule shape as well. Drag that up so that it matches our player. Now, if you want to give them a head or anything like that, you're welcome to. But in the case of this tutorial, we'll go ahead and not do that. Now, we'll also come in here and attach a camera to our player. So we'll type camera. And we'll pull this back something like this. Something that's nice about the new Godot build, they have a camera preview here, which makes it way more easier to see what you're actually trying to see when you're doing this. Before, we used to have to click preview like that every time, and this really helps. So I really appreciate the devs for building this out. Once we have that, we should be pretty much good to go. So we'll right click our character body, rename it. We're going to name it player, and then we will right click and attach a script. And we'll stick with player and we'll come up here and make it C#. So you'll see player.cs and we'll hit create. Now you'll see that Visual Studio code comes up. Now, if you've never set up Visual Studio Code on your machine, be sure to check out my tutorial. I run you guys through how to set all this up. Now, when we're doing a character body, you'll notice that it didn't give us a template. My guess is if I take a look, it never got a template attached to it. So let's try deleting this. So I'm going to go ahead and delete that, hit the delete key, and then I will detach my script. And let's try that again. So we'll attach a script. We'll do player.cs, and then we'll make it have the character body 3D basic template, and we'll hit OK. And that will basically fill out a bunch of our code for us. Now, this here is Visual Studio Code. So if you guys use Visual Studio, you're welcome to use that. In my case, I'm going to just use Visual Studio Code. First things first, we want to get rid of the ability to move forward. So since we want to get rid of that ability, we need to come in here and rip out some of this code. So we'll come in here and we'll rip out all of this area here. We'll get rid of that. And we'll write some code here. So when a player wants to go between lanes, we need to basically segment our world up into those 3 lanes. We only want the player to move those 3 lanes. So since that is the case, we only need to have an array of lanes that the player can be in, and then we just need to keep track of which lane they are in. So I'm going to come up here and type enum lane, and we'll go left, comma, center, comma, right. Now we can also make these set to values by hitting the equal key. So equals -1, equals 0, and equals 1. And this enum is going to allow us to define lanes. So I'll type lane, target lane is equal to lane.center, comma, and then I'm going to copy and paste this and do current lane. Because when a user wants to go from one lane to another, we need to say, here's where we are, here's where we want to go. So that's kind of the purpose of these 2 values. Now, if we come down here, we can say float target x is equal to target lane multiplied by some kind of value, right? When we switch from one lane to another, we need to move by a specific value. So in this case, we will have a distance. So let's do a integer lane width, and let's set that equal to something like 2. And then we can come in here and type lane width like that. And then we can cast this as an integer. So we'll do int like that. And that's going to force that enum to be an int. And the reason why is because we're doing this little multiplication here. So we kind of need to do some small adjustments to make it work. So then we need to basically move our player. So we'll say position equals position dot lerp. And then you'll see that lerp, well, providing that this doesn't actually ruin my day here. So let's try to get this to come up with the documentation. That would be nice. And you'll see it takes a vector3, 2, and a float weight. So a vector3, 2 means that we need to say, here's where we want to go. So in our case, we want a new vector3, and then we can instantiate this vector3, and we can add in different vectors. Now we want our x value to be where we want to go. So where do we want to go? Well, we want to go to our target x position, like so, comma, and then we need to put a weight. So how fast we want to move in that lane. If we type delta, that's going to make us move at delta speed, right? Which is really slow. So what we can do is come up here and say int lane change speed, and we'll make that equal to 5, like that. And that means that we could take this value and multiply it by lane change speed, like that. Simple enough. Now you'll see we have an issue here. No vector3 argument was given. That's because I'm crazy and forgot to do 0, 0. And now you'll see it gets mad because it cannot convert a double to a float. So let's just make this a double like that. And that should help us with keeping this properly set up. Now you can see it's still mad, syntax error, comma. So we'll add a comma. And then you'll also see, once again, it's still mad because it looks for a float. So let's do like that. And then we'll pass these guys into their own little braces like that, their own little parentheses. And now we can come in here and basically choose where we want our target lane to be. So right now we're setting our position, but we're not doing anything with it. So we need to actually tell Godot when we want to change our lane. So let's come in here and say if input.isAction just pressed, and we'll pass in the action that we're looking for. So UI underscore left and target lane is greater than lane dot left. Then let's go ahead and do target lane minus equals 1. And the reason why we're doing it this way is because if we want to move from one lane to another, we're basically going down the values, right? So our target lane is minus equals 1. So our lane becomes one value lower. So it goes from left to center, from center to right, and then vice versa. And that should hopefully work. And then we could basically just take this, copy it, and paste it, and then do UI right like that. And then we can do right and this way, and then change this to plus equals 1. And in theory, that should do all of our movement. Let's go back to Godot here. Let's hit play. We'll save our scene, and let's hopefully see what happens. Now you can see my player is falling through the floor, so that's not a good sign. If I do left and right, it does seem to work though. So awesome. That does seem to work. If we click on our CSG mesh here, let's add collision to it. So we'll come in here and use collision like that. Now you'll notice that our movement is a little bit weird because we are dropping really slowly and jumping really slowly. And the reason why is because our velocity is being affected by this position here. Since we're setting our position, it makes things a little funky. So what we can do, we could come in here and do math F instead. So we could do .x and then come in here and say, instead of doing this, we'll comment that out and just come in here and go math F dot lerp. And then we could pass in our values. So a double from, a double to, and a double weight. And then we can come in here and just say position.x, comma, target x. And then we could pass in our actual lerp value. So this float delta change speed right here, we could just copy and paste that in. So it looks like we're not able to just set position.x. So what we could do instead is do a new vector 3. This is going to be our x vector. And then we could come in here, comma, position dot y, comma, position dot z. And then that should stop it from getting too upset with us. And we can see if that gives us a little bit of a better feel. Now I'm going to come in here. I'm going to add my environment and I'm going to add my sun. That way we can actually see stuff. I'm going to hit play and see if that gives us a better result. And it does. So you can see it feels a little bit better and it kind of moves a little bit better. Awesome. So now that we have that, let's talk about how we can actually get objects to spawn and we can start dodging our objects. Now, objects are pretty easy. What we'll do is we'll first right-click add in a child node, and we're going to add in a node 3D, and we're going to call this obstacle container. And I'm going to right-click add in a child node, and I'm going to build out an obstacle. So I'm going to make this into a CSG box, and we'll make it have a material, and we'll zoom in on this guy as soon as we get done with it. So I'm going to pull this guy up. And then I'm going to drag this guy up. So that way we got this big old box right here. And that should work. I'm going to make it a red color because red is always bad. So we'll make it a red color so that way we can have something that's going to fly towards us, right? And then all we really need to do is right click, attach a script, and we'll call this obstacle.cs. And then we'll come in here and basically make it fly at us. So we'll say position is equal to a new vector 3. And we'll do a new vector 3 plus equals a new vector 3. And we'll pass in our x value, which is going to be position.x, our new y value, which will be position.y, and our new z value, which we need to come up with a way for it to fly at us. So what I'll do is I'll come up here and I'll say public float speed like that. And we'll need to set that to some kind of default value because if we don't, it's going to basically not allow us to move at all. So in our case, I'm going to move by 10 about, and then we'll come in here and basically do position dot z plus speed multiplied by float delta, like that. Now, this is going to cause a slight problem. And the reason why is because this is the conventional way that people think of when they're going to do a process move like this. And the problem is that you're going to be adding your position X and Y to this. And we don't want that. So what we'll do is we'll hit get rid of that. So we'll delete that and we'll just be moving on this section here. So we'll hit Control S. We'll come back to Godot. We'll hit play and you'll see it's coming towards us. And we just avoided it. If we refresh it, you'll notice that it'll come towards us and it'll hit us and, well, apparently go through us, which means we don't have collision on. So we'll click on our CSG mesh and add in collision. So that way it has collision. I must have missed that part, but we'll try it again and you'll see it's going to come at us. Then if it hits us, it'll start pushing us backwards. Now, this is where things are going to get interesting because you can see it successfully pushed us backwards. And the nice part is you can see how much runway we have here. So it's a way to give your player some form of life. So if you wanted to, you could move this really close to the edge. And then if you hit play, you'll notice that our life is much shorter. So you'll see we're gone almost immediately. So that's kind of the fun part, is that you guys can make it however you want to make it. Now, in my case, I think the amount of time that we have is perfectly fine, so that should work. So now we just need these guys to spawn. So in order to do that, we need a game manager and we need to separate this out. So I'm going to change the name of this to standard obstacle, and I'm going to drag that down and save it as a scene. And then I'm going to come in here, rename this as game manager because I always like to have a game manager. Then I'm going to remove my standard obstacle from the scene and I'm going to right click and add in a script for my game manager. And I'm going to call that game manager.cs because I always like to have a game manager. And so inside of our game manager, we're going to need to build out how we're going to spawn our stuff. So first things first, we need to get an array of objects to spawn. So how we're going to handle this is we're basically going to have an array of objects that that we can drag into our inspector, and then that's how we control what we're going to spawn. So first things first, I'm going to export out a value because we want it to show up inside of our inspector. We could basically export out a value and work from there. So we'll say export public array, and then I'll do bracket, and I'll do packed scene like that. And we'll say obstacle scenes. And I'll do this as parameters. So get semicolon set semicolon, and then we'll do is equal to a new array of packed scenes like that. And that's basically going to allow us to handle arrays, multiple objects inside of our inspector. Now you'll notice that we have this little error here. So this is actually really common. So if you hover over here, you'll see it says system.array. And the reason why is because system is here. So we need to get rid of that. But what we'll need to do is make our array have a reference. So we'll click on this guy and you can see using Godot.collections, and that will solve our problem. Now I'm going to do some preventive coding, and I'm just going to come in here and do a second one because we're going to want one for power-ups and things like that. And I'll just kind of throw that in here for right now. So we'll do power-ups as well. Now you don't have to do that, but I'm going to do that just because it's going to be a bit simpler for me. So first things first, how are we going to get our stuff to spawn? Well, what I'm going to do is I'm going to make a timer, and I'm going to make that timer actually time when we're going to spawn stuff. So we'll go into our game manager. I'm going to right click, add in a child node. I'm going to add in a timer, and then I'm going to command duplicate that, and we'll call it obstacle spawn timer. And then I'll add one more. So that way we can have score. I'll just do this as, again, preventative coding. That way it's just done for us. So that way we don't have to go back here. So I'm going to go into my node. I'm going to say on timeout. I'm going to copy this guy and I'm going to connect it to my game manager. Now, if you come back here, you'll say public void on score timer, time it out like that. And if you hover over here, you'll see that the signal here doesn't have anything in it. So you can see right here how this guy over here has node like that. That's how you know what type of function you need to build. So in our case, we don't need to add anything special. We can just have that. And then I'm going to click on obstacle spawn timer, do the same thing, timeout, copy that, hit connect, and then alt tab over here, and then come in here and say public void paste, and then we'll do that. And then control S our project here. Now, that means that whenever this guy fires off, it's going to actually run that bit of code here. So it'll run this little bit of code. And what we'll do here is we'll basically have it spawn our obstacles. Now I'll make this a little bit bigger so you guys can see what's going on here just in case. So I'm going to hit control, I believe it's control plus, and I'll make this get a little bit bigger for you guys. Now, when we're doing our spawning code, first things first, we're basically going to grab a random element out of our array. So you can see we have an array here, and we want to grab a random one, right? Because we don't want to have a set schedule of what's going to come into our spawn code, right? So it could be 2 things that you need to jump over, it could be 2 things you need to slide under, or 2 things that you need to dodge, right? You want to make it so that things are random so that it doesn't allow the user to plan ahead, if that makes sense. So we'll come in here and we'll just say int scene index is equal to, and I'll say gd.randi, and that's going to give us a random integer. Now you'll see it's a little mad at us. It says cannot implicitly convert a uint to an int. An explicit conversion exists. Are you missing a cast? So that means that we need to actually cast this as an integer. So I'm going to do a little bit of extra coding beforehand, but I'll do a modulus and I'll type obstacles scenes.count like that. And then I'm going to wrap this in parentheses like that. And you'll see that it's going to say, hey, you can't do this because it's a long to an int, right? So we need to cast it to an integer. So I'm going to do this and type int. Now, the reason why it's a long is because rand int can give you really anything. And doing obstacle scenes.count is going to limit it into that 1 to whatever range that we're looking for. So it gives us that limit to our actual index. And now I'll pull back the thing we're going to spawn. So I'm going to say packed scene obstacle scene is equal to obstacle scenes bracket scene index. And there we go. And that's basically going to give us back what object we're going to spawn. And now we can spawn it. So we can type node instance is equal to obstacle scene dot instantiate. Now, if you want to, you could do this as a node, or if you can guarantee it's going to be an obstacle, you could actually do it as an obstacle as well. But then that means that you're going to need to cast this as an obstacle like that. And that does work, but it's just something to keep in mind that it could crash your game if you put the wrong type of object into this. So just keep that in mind if you're going to be doing that. So in my case, I'm going to get rid of this and I'll do an additional check. So I'll say node like that, and I'll come in here and I'll say if instance is obstacle like that, and then I'll say obstacle instance like that. And what that's going to do is it's going to typecast this. So we spawned the object and we're not crashing our game. And that's a way to get around these kinds of things, is you can typecast something through an if statement and then use that typecast version instead. And it just makes it a little bit safer for you to use. And now all we have to do is handle our object. So you can come in here and just say int open lane is equal to, and if you remember, just like we did before where we handled our player scene, we need to pick a section to spawn our stuff in, right? So remember how we did left, right? Very similar to how we would handle this. So what we'll do is we're going to come in and we're going to pull back a random integer, and then we're basically going to say, okay, now I know that this is where I'm going to spawn my object. So I'll type or parentheses int gd.randi modulus 3, because we only have 3 elements that we can work with here. And we're going to need to put in these parentheses here, and there we go. And now we can come in here and spawn our object. Obstacle scene dot position is equal to a new vector 3, and we'll need to place it in a specific spot. Now, the only way for us to know where we're going to place it is by having a class variable to work with. And the reason why is because if you remember, our lane positions are -2, 0, and 2. So we want to make sure that we have an array of those objects. So I'm going to say private read only float bracket underscore lane positions. We're going to make that equal to bracket, and we'll go -2.0f because it's a float, 0.0f, comma, and 2.0f, like that. And that will give us a very basic array to work with. And then we'll just come down here. And when we want to spawn our stuff, we can basically determine which lane we want. So I'm going to go underscore lane positions, bracket, open lane, like that, comma, and then 0. And then we need to determine how far back we want to spawn this object. Now, in my case, what I would want to do here is I would want to make that into an exported value. So I'll come up here and I'll make an exported variable. So bracket, export, and then we'll say public float spawn distance, and I'm going to do it as a property. So get comma set comma or semicolon, and then I'm going to make that equal to -20.0f by default. Now you could set this to -50. That's probably a better value anyway. So maybe I'll leave it at -50, but for testing, -20 is a good value because it spawns them really close to you. So that way you can see if it's working immediately. So we'll say spawn distance, semicolon, and then we'll add it as a child. So we need to add it as a child, and you can see we have an obstacle container here. So I'll just tell that to add it as a child. So I'll say get node obstacle container dot add child, and I will add my obstacle instance as a child. And there we go. Now, something that we're going to have to take a look at is if we look at our standard obstacle, it is at the center of the scene here. So I'm going to not delete it. That's a bad move. I'm going to pull this guy up like this, so that way he is slightly higher, and that should help with handling some of the struggles that you might run into with future positioning. Now you can see that it's still at the center here of this guy. So I need to come in here, add in a static body 3D, and then let's set this as the actual scene root. And the reason why is because this needs to be at the dead center of the scene. If it's not, when you spawn it, it's going to have problems. So it's just something to keep in mind. Now, once we have this, we should be able to click the build button right up here in the upper right-hand corner, and it should hopefully allow this to show up with our obstacle scenes. If we click on array, we hit 1, we can drag our standard obstacle right in there, and it just works. And now we can hit play, and it should, in theory, spawn our objects. Except for it won't. Now you might be wondering, why is that? Well, if we take a look at our obstacle spawn timer, you'll notice that it doesn't have auto start on. So we're going to need to turn that on. Now we can do this one of two ways. In my opinion, I like to do things through code. So I'm going to come in here, type get node, quote, and it is called the obstacle spawn timer. So I'll copy that, paste, and I'm going to hit dot start. And in order to typecast this, we'll type timer like that. And then we can hit dot start, and that will start the timer. Now I'm going to duplicate this and just do a little bit of preemptive coding. Again, we're going to grab our score as well and do that. That's just going to help with the flow of the tutorial and make things a little easier on us. And now we'll come in here, we'll hit play, and you should see in about a second, in theory, it should run. but unfortunately it's not. So that leads me to believe that something's broken here. So it did find our obstacle timer. It did hit start on it. It's waiting for 1 second, which is fine. It does have stuff. I don't see anything in here that could be an issue. So let's make this an auto start and let's see what happens if we do that. It could be that our code isn't starting it properly. No, it seems to be fine. So let's come in here and say gd.print spawning object. And let's take a look at this really quick. So spawn index, obstacle count, that's fine. Or at least it should be fine. And this is setting that. I mean, that should be okay. So I'll come in here and copy this guy. Whoops, did not mean to do that. I'll paste it in here and do spawning obstacle. Let's see what happens if we do that real quick. So it is spawning an object. If we take a look at our remote, let's take a look. Well, it's definitely not doing what we need it to do. Is the standard obstacle? It's not the right type. So you can see right here, obstacle.cs. That's because this is not the right thing. So we'll detach that and we'll drag it onto our static body. So that was my fault. So now in theory, that should fix our problem. So we'll hit play. Let's see if that fires it off now. All right, well, we have a crash, which isn't a good thing, but that's better than nothing. So script inherits from CSG cannot be a static body. So that's totally fine. We'll come in here and type static body 3D. And that way it inherits from the proper thing. So basically what's going on here is C# is mad because we changed the type of object. It was a CSG mesh and now it is a static body. So the code's getting mad. It's saying, hey, you can't do that because they're a different class type and the Godot compiler doesn't know what to do with it. So that's the reason why it's breaking. So if we refresh it, you'll see now it's spawned in the stuff and it's random. You can see we got 2 3s, and there we go. Not too bad. Now, something else that we could do if we wanted to while we're in here is if we go into our game manager, we could actually create a little bit of randomness in here. So you can see that we have a scene index here. We could actually come in here, copy this guy, and say, hey, if this is an obstacle instance right here, instead of just spawning the obstacle and doing the thing, we could actually come in here and do a int rand and then change this to a modulus of 2. Well, actually it goes from 0 n minus 1. So if we do 1, in theory, it should be able to only give us 0 and 1. And then what we can do is say if rand is equal to 1, then do this bit of code here. Else, if it's not equal to 1, then we'll spawn a double obstacle. And a double obstacle, I think, will be a lot more fun. It'll be different, right? So we can come in here and say, let's get a open lane exactly like we did before. So we'll grab this guy, we'll paste it. And then what we can do is come in here and say, for I, int I in I length, right here, we have to come up with a length. So in our case, I'll do 3, and then we'll come in here and say if I does not equal open lane, like that. And then we can basically steal from up here and pull back basically what we're doing here. So we'll just grab these two guys, copy it, and paste, because we want to spawn 2 of them, so we're going to need to do it slightly differently. And instead of doing a node, we can just say obstacle scene, and then we can just come in here, and actually we don't really need to redo this. So we'll just take this and do obstacle like this, and we'll copy this guy and we'll say as obstacle, and then we'll say current obstacle. And then we can basically steal this bit of data as well. So we'll just copy this guy, paste, and instead of open lane, we'll just do I. And then we will also do the add child right here, paste, like so. And we'll grab current obstacle, current obstacle, current obstacle, because we want to change it over to the new code to handle that. And then once all of this is done, we will queue free this instance up here. So we'll type instance dot queue free because we don't want that instance just existing out there. That's really bad for memory. But this should, in theory, give us the ability to have multiple different obstacles, one spawning with 1 and then one spawning with 2. So if we run this, it should, in theory, give us some with 2. So you can see 2, 2, 2. So you can see I'm debugging here, and you can see it's spawning 0, 1, 1, 0. So this is interesting because it shouldn't be doing that. So you can see this is saying if rand is equal to 2, I'm getting back 0s and 1s. So I guess we should do if rand is equal to 1, then do that. So let's try that. Because I guess we need modulus 2 to keep it within the 2 values. So you can see here, now we're spawning the way you would expect. And of course, we can scale this up to as many lanes as you want because, you know, it might be that 1 is not enough, right? So you could also do 3, 5, right? So you guys can expand this however you would like. And now let's make different obstacle types. So let's do our jumping obstacle and our crouching obstacle. So if we head back into Godot here and we come into our standard obstacle, let's just duplicate this scene. So we'll duplicate it. We'll call this the jumping obstacle or lower obstacle, if you want to call it that. And what I'll do is I'll come in here, scroll down into our size here, and I'm going to adjust our size to be something like 6.5 and something like maybe 1 will be fine. Now, if we double check our standard obstacle to make sure, oops, good thing I checked because this is the wrong scene. Let's open up our lower obstacle first, and then let's change this to 6 and then 0.5 and then 1. And we need 6, not 5. And once we have this, we'll double check our standard obstacle, make sure it's not getting affected. It shouldn't be, but just in case, we'll rename this as lower obstacle. And what we'll do is we'll come in here and we can type out this obstacle. So something that we should probably do is create a way to denote what is a lower obstacle and what is a standard obstacle, right? Because there might be a time when you need to determine if you need to spawn 2 of them, right? Because you don't want to spawn 2 lower obstacles and you don't want to spawn 2 upper obstacles, right? Because they would be overlapping on each other. Now I am going to pull this guy down. So I will pull him down just a tiny bit. We're going to put it somewhere like that, give or take. And basically, if we go into our code, we can create an enum. So we'll create an enum and we'll call it obstacle type. And then we'll say bracket, bracket, export, public obstacle. And by default, we'll call that obstacle type dot, and then we'll just say standard. Now I'm going to grab this, copy it, paste, and we'll put a semicolon there. We'll hit comma, copy, paste, paste. We'll do lower and then upper like that. And I don't need a comma there. I think we should be okay. Now you'll see it says inconsistent accessibility field type obstacle type is less accessible than field of current type. The reason why that is because this is not a public enum. So we'll make it a public enum so that people can see it. And that will solve that small problem. And now if we head back here, we click the build button, you'll see that if we click on our thing, we can choose the type. So we'll choose a lower type obstacle. And on our standard, we can come in here and validate that it says standard. It does. So we are good to go. And now I'm going to basically duplicate this lower obstacle as well. And I will call it upper obstacle. So we'll duplicate it. And we will come in here, grab our lower obstacle, and just pull it up to about 2 meters, or about a meter, I should say. So you can pull this up to about right here, give or take, and that should work fine. Now I'm going to change the name of this as well to upper obstacle as well. Now I know that I'm doing a bit of preemptive coding here, again, by handling it beforehand, but it's just going to be easier while we're in here to do that. I'll click on this guy and change it to an upper obstacle as well. And if we go into our node 3D here, we can go into our game manager. We can grab our lower and our upper and drag them in here. So we can just grab this guy, drag it in, grab our upper, drag it in, and there we go. And now our game manager should be able to automatically spawn these. But if you look at our code only handles the one case of if it is a standard object here. So what we can do is we can say if is obstacle, and then if instance dot obstacle instance dot, and then if you remember, it is the obstacle type, current type. So if current type is equal to obstacle type standard, then do all of this code here. So we'll bring this down here and put it like that. And then else we're just going to spawn it like a normal object. Now you'll see here we actually instance it just like we would. So we can just come in here and basically grab this, except for we don't want to do a random lane. We always want to spawn it in the center. So since we always want to spawn it in the center, we can basically just grab this guy, I guess these two guys here, and then we can basically paste it like that. And instead of doing an open lane, our lane is always going to be the center lane. So since it's always going to be the center lane positions .1 will handle that for us. And there we go. And that's basically all we need to do to spawn these guys in. Very simple to set that up. So now we should be able to format our code. So Alt-Shift-P and then format document. And that's just going to format our document so it looks good, because we want our stuff to actually look good when we're working through it. So now we can hit play, and you should see, hopefully, there's a lower. You can see that we can kind of hop over it. This we really can't, because unfortunately we can't crouch yet, but we can spawn them, which is good. So it is working, which is good. So first things first, right? Our obstacle's too low, right? It's not hitting us. So let's bring this bad boy up a little bit so we can actually get this to work. So we'll grab our lower obstacle. We'll make it a bit taller. So let's bring it up quite a bit. Let's take a look at our static body. That should work just fine. That should be, in theory, the right size. So let's try that. See if that gives us a better result. So there we go. Now you're getting bumped and you fall. Perfect. That's exactly what we want. And we do have the ability to jump by default. We never disabled that ability. So that should just work. Now you'll also notice that we can actually jump over our upper obstacle. So that's going to be a problem that we're going to have to solve. So the first thing that we can do to solve that is to make it taller. First things first. Or if you guys want like a mid-level obstacle, you guys could always make a duplicate, right? But what we can do is just grab our upper obstacle, make it just a touch bigger, and bring it up. So I'm going to come in here, bring it up. It's always hard for me to see the lines here because unfortunately with the backdrop, it makes it a little hard. So we'll pull this up about here, and I'm going to make this just a bit taller so people don't try it. And that should solve our problem there. And now all we have to do is just make it so we can crouch. Now, in order to make a crouching system, we need to go into our player and actually make some adjustments. So let's head over here. Let's take a look at our player. You can see that our player has a collision object here. And this collision shape right here is what defines the player's collision, right? Well, if we duplicate this and we have a standing collision and a crouched collision like that, we could actually come in here, make this nice and small. So a singular ball almost. If we actually hide our mesh instance, you'll see what I'm talking about here. So it's kind of hard to see with the backdrop here, but you can see how this is just a ball. If we take a look at our standing collision, you can see that it also got affected. So let me double check that and change that. So if we click on our crouched collision and we grab our capsule shape, we make it unique, and then we pull this down. That's my fault. If I can grab it, there we go. Drag that guy down to make it small. So if we hide our mesh instance, you'll see that I have a small little sphere inside of our sphere. If we grab that crouched collision, we go to X value like this. You can see It's always hard to see because the sun is the same color or the sky is the same color. You can see how it's right like that. So if I drag this guy down like that, when we instance in our object, it should never hit this. And we can have two collisions. It's not going to hurt the project any. No one's going to know that two collisions exist. But now we can toggle the visibility of this one, and it'll stop the user from colliding into things if they duck underneath it. So if you look, you can actually have disabled on and off, and that's kind of how you can handle it. That's also kind of how they handle iframes, right? They just disable the collision for that time frame. So now we can come in here into our player, and we can actually add the ability to crouch. So in order to do that, it's really simple. So we can come in here and just say if is action input.is action just pressed, and we can do UI underscore down because Godot has that by default, so may as well use it. Now, once you press that, we can basically come in here and set our standing collision to nothing. So we can go get node, collision shape 3D, and then we can pull back our node. So if you take a look, you have the player node and then the standing collision. So we'll go back here, standing collision dot disabled, and we'll make that equal to true. And then I will put a semicolon and then copy this because we're going to need to disable it. So how are we going to handle disabling this collision? You can do lots of different ways, but my favorite way to handle it is by having a sliding duration. So I'll scroll up here and I'll say private float current sliding duration. And I'm also going to add in a bracket export. We'll make that a public float sliding duration. And by default, I think that sliding duration should be something like 0.2. So we'll make that equal to 0.2 float. And then we can also add in a ready function to set our current sliding duration. Now, you don't have to do it this way, but I prefer to do it that way because it makes things a little bit easier. So we'll say public override void underscore ready, and then we'll say current sliding duration is equal to sliding duration. And now when we come down here, we can say if the press button is down and sliding duration does not equal 0, current sliding duration does not equal 0, or I guess technically you could say is less than or equal to 0. That way we can do a little bit of preventive coding there because there could be a possibility it could go into the negatives and then you'll never get it to work. So we'll do that. Current sliding duration is equal to 0. Then that means that you can slide, right? So we'll say that we disabled our collision, and then we'll say current sliding duration is equal to sliding duration. And that'll basically reset our counter. And now we can basically start counting. And then if our sliding duration is less than or equal to 0, then we can no longer slide, right? So we could basically come in here and say current sliding duration minus equal parentheses float delta, because unfortunately you can't minus a double like that. So, well, technically, you can, but you have to, this is a float and this is a double. So you want to typecast it so that it actually can be subtracted from each other because they're two different types. And then we can just say get node if current sliding duration is less than or equal to 0, then we can go ahead and disable or enable the collision like that. And now, in theory, that should allow us to slide. So if we show our mesh instance, we hit the play button here, in theory, this should work. So you'll see we got this guy, so we're going to jump over. Now we got to slide, and you can see that we actively slide underneath it. And there we go. Simple enough. Awesome. So now we're starting to get a game here. So now the question is, okay, well, as with all games, we need to have some kind of score, right? As you're playing, you need to get a high score, right? So how do you get a score? Well, a score is really easy. All you have to do is create the UI element for the score, and you need to keep track of that score. So in order to create the UI element, we just right-click our game manager. Let's add in a control node like so, and then we'll make that a full rect, which in here, we just do it like that. So we have a full rect container. And then in the upper right-hand corner, we're going to add in a object for that. So we'll add in a label. So we'll grab label, and then we'll just click this guy, upper right-hand corner, nice and simple, score, colon, space, and well, I mean, that's really about it. Now we could pull this guy just a bit over into the corner. So it's not quite directly in the corner because it's going to look a little bad to do that. So I'll do that real quick, and we'll make this and expand it just a tiny bit. You want to make it look like the user's achieving something, right? So you want to give them some ample space here. And then we can call this the score label, and then we'll call this the UI manager. Again, I always like to have managers. They make things just so much easier when you're scaling up your game. If you want to make this into a real game, you make managers because they handle things, they segment your code, it makes things more efficient. So that's just something to keep in mind. Now, we'll go into our game manager here, and then we're going to add in a public int score like that. And we'll just default that to 0 like that. Nice and simple. Then we'll come down here and on score timeout, score plus equals 1. Nice and simple. But now we need to tell our UI that we've updated that value. And in order to do that, we need to do what's called a signal. And a signal is a way to get that data without actively causing some, without directly referencing other things. So we'll come up here and we'll create a signal. So inside of C# for Godot, you need to do signal up here, and then you need to do what's called a delegate. So we'll say public delegate void score updated event handler. Now the event handler is the part that's really, really important. And the reason why, and we'll pass in an integer score here. The reason why is because Godot uses this as a way to register whether it's an event handler or if it's a subscription. So that's just something to keep in mind. This just informs Godot that that is a signal, and the delegate is the C# way of creating an event. So that's basically what this all means. Now, if we want to, whenever our score gets timed out, we can broadcast this event, and that way anybody that's interested in that data can now receive that data. And the reason why that's useful is because it allows us to have a fuzzy connection to through our code, and it makes things a little bit easier to manage. So we'll type emit signal, and we'll pass in signal name dot, and you'll see if we type score updated, it doesn't have the event handler. And that's because the event handler kind of registers it with the Godot subsystem, so it knows what is an event or not. So that's how it understands. And then we'll pass in our score like that. And now we can head back to our game here, and then we can subscribe to this event. So if I hit build, you'll see if I go into node, we have score updated right here. And then we can come into our UI manager. We can right click, add in a script and call it UI manager.cs. And then we can come into our game manager, score updated, and then connect it to our UI manager. And I will copy that, connect it, and then we'll go into our UI manager and say public void paste bracket bracket int score. And again, how I know that it's score is because you can see right here, score, integer. And that's how I know to say this is an integer and it is a score value. And now I can just say get node bracket label, because it's a label, and we can pass in our label. So it's the score label right here. So we'll copy that, and I will hit quote score label dot text is equal to $ score colon space bracket score. Easy enough. And the reason why I did the $ is because then it allows us to just inline that, and it makes it nice and simple for us. And now that should update our score. So if we head back to our game manager, let's validate that we actually are running our timer, which we are. So in theory, this should all just work. So we'll come in here, we'll hit play, and you'll see that now we have a score value that is going up. So we can now jump. Well, in my case, I didn't, but we can jump, and it does seem to work. And so now at this point, we have a score. We have the ability to jump and crouch underneath obstacles and things like that. How can we spawn additional objects? Like, for instance, a coin or something like that for us to be able to make the score go up faster. So in order to do that, we first need to build out our coin. So let's go to scene, new scene, and let's do a 3D scene. Now I'm going to right click, add a child node. I'm going to add in a mesh instance 3D, and I'm going to make this into a small box mesh. So I'll go like this. I'm going to pull it up just a tiny bit like so. And then I'm going to make it nice and small. So we'll scale that down, and I'm going to make it gold. So that way it's like a coin, right? Because coins are usually gold, at least in most video games. So we'll do that. We'll go to albedo, and we'll change this to a gold color. And you can see right there, there's our gold color. Now we need the ability to actually collide with this object. So let's do a right click, and let's add in a child node. Let's add in a collision shape 3D, and I'm going to make that collision shape a box shape. I'm going to bring it up like this, and we will make it the proper size. So I'm going to go to Z like so, and we'll pull these guys up and over and down so that way it fits. We'll go to X and do the same thing. So we'll make it nice and connected just like that. And now we can't really use collision shapes without having some kind of object that takes collision. So for instance, a character body, a static body, a rigid body, or in our case, an area. So I'm going to right click, change the type to area 3D, and that should do it. Now, if we take a look at our collision, you'll see that says a non-uniform scale. So let's take a look at our transform. You can see that this is not uniform. So we'll hit 1, and we will actually get rid of this little chain. 1, 1, and 1, and that should solve that problem right there. I must have bumped something earlier or something like that. So we'll just set that to 1, and that should be fine. And we'll call this coin, just like that. We'll hit Control S, and we'll save this as coin. Now, in order to handle coins, they're actually really simple. First things first, when we collide with our coin, we're going to need to make it disappear, right? So what I'll do is I'll come in here, I'll right click, attach a script, and I'll hit coin.cs. Now I'm also going to come back over here, and I'm going to grab my area node, and I'm going to connect my area entered onto my coin as well. That way we can have a function for when the user collides with it, it gets disappeared. So we'll say public void, and we'll paste on area entered. Now on area entered does have an area 3D. So we'll type area 3D area, and that way we have something to work with. Now, if anything collides with this object, what we'll do is we'll just queue free. Like that, nice and simple. And then we'll come in here and we'll just basically do what we did before. So we'll say vector 3 in our obstacle. So if we go to our obstacle and we look at our process, you can see right here, we can just basically copy this guy and paste it in. And then we can go to our obstacle again and grab that speed value right here and paste that in as well. We'll just come in here, paste. Now what I'm also going to do is I'm going to create a obstacle type effectively for our coin as well. So I'll just come in here and do that. But instead, I'm going to change this to pick upable type. And I will change this to pick upable type. And we'll change this to coin. Like that. Now, you'll notice that this is called coin. I don't like that, so we'll call this a pick upable. That was because I wasn't really paying attention when I created this, so that's my fault. But I will show you guys how to fix that. So you can see how I changed this to pick upable. The title of this needs to change as well. So you got to come in here and rename it. And then you need to re-reference everything. So right click, detach, and then pick upable as well. So you just kind of put that on there and there you go. Now just know that if you ever catch that later, it's going to be a lot of work to change it. So make sure you don't make that mistake. Now, if we hit build, this should build and it should show current type is coin, which is perfect. That's exactly what we want, because when a player collides with it, we're going to basically check its current type. And then that's how we're going to determine if it's a coin or if it's something else and what we should do and how we should affect the player. So now we'll head back to the player and get that effect going. So when we do our player, if we collide into a coin, what do we do? If we collide into an area object, what do we do, right? Well, let's go in here. Let's first allow us to collide with the coin. So right click, add a child node. Let's add in an area 3D, and then let's also duplicate our standing collision and just put it on there. That way we have the collision object for our area 3D. And when our area 3D has an area that enters it, what are we going to do? Well, we'll connect it to our player like so, and then we'll scroll down here to the bottom and we'll say public void on area entered, and we'll say area 3D area, like that. Nice and simple. And then what we can do is then we can go ahead and do stuff with it. So what we'll do is we'll say if pick upable dot current type is equal to pick upable type dot coin, like that. Then we can basically do stuff with it. Now, in our case, how are we going to notify our game manager that we picked up a coin? Well, just like the game manager, we can just create a signal. So I'll just grab this guy, Control C, go up to our player, go to the top, enter, paste that bad boy in, scroll down here, and then come in here and say emit signal, signal name dot score updated, comma, and then we can pass in a score value. Now, in our case, are our coins going to have different values? And that's a question, not a statement. We can come up with whatever we would like to do here. So if I go back to my pick upable, I'm just going to come in here and say public int score value. Now I'm going to make that equal to 10 by default. And I'll also export that out so that way we can make changes to it later. That way, if we want to have multiple types of coins, some are worth more, some are worth less, right? We can go ahead and do that. Now I'll go back to my player and I will say pick upable dot score value, like that. And now I can come into my world here, my game, and I can hit build and I can click on my player, and on score updated, we'll copy that, click it onto our game manager, and then go into our game manager here, scroll all the way down. This is going to pass in an integer, right? Score, because we built this, so we know what it has. And what we'll do is we'll come down here, grab this guy, copy it, and paste. And instead of plus equals 1, we'll say plus equals score, and that should allow us to pick up our coins. And now at this point, we can go and actually update our spawn code here to actually spawn in our coins. So if we take a look at our spawning code, we can come in here and basically change how we handle this here. Determine whether or not we're going to spawn a pick upable object or if we're going to spawn in a obstacle. So what I'll do is I'll come in here and say float rand value is equal to gd.randf, like that. And that's going to give us a random float. And now we can just say if rand value is less than, and we can come up with some kind of value. So if we want to, we can make that an exportable value so we can change how our code is set up. So I'm going to come up here and say public float pick upable spawn chance. We're going to make that equal to something like 0.03f. That way it is some kind of, easy value here. Now you could make this exportable. So if you go print, bracket export, then that way you can make adjustments on the fly as you need. Now I'm going to come down here and I'll say pick upable spawn chance. And if it is less than that value, then I'm going to spawn a pick upable object. And then I'll just say else bracket, and then we'll just basically say else we're going to spawn one of these guys in right here. So that way we can spawn our obstacles and we can spawn our pick upables and they don't overlap on us. So now we can come in here and do basically what we're going to do here, right? So all of this is basically the same stuff. So we'll just copy this right here, paste it, and then we'll say instead of obstacle scenes, we're going to change this all to pick upable scenes. But instead of obstacle scenes, we're going to go and make them into pick upable scenes. Or I guess in this case, it's power up. So I think I'll probably just change this to pick upable. That way we can just keep our name consistent. So I'm going to scroll down here and do pick upable scenes, and change this from obstacle scenes to pick upable scenes, like so. Lowercase that p. There we go. And that will basically allow us to spawn in our scenes. So now we can say if instance is pick upable, and then we can just call it a pick upable. Then we can say if pick upable dot current type is equal to a pick upable dot pickup type dot coin. And I know that right now, right, this is just one coin, right? So, we only have one pick upable, but why would we add this code in here? And the reason why is because it's going to make it easier for us to add stuff later. So it's just for future coding for you guys. So once you have this, then we can basically spawn our coin, just like we did down here. So you can see here, we actually spawn stuff like this. So I'll just copy this entire code set, paste it, and easy enough. Now we just grab our pick upable like that and copy it like that. And that's it. That's all we have to do. And now, in theory, we should be able to bring our game in here, hit play, and it will build, hopefully. And you should see, well, we have some errors, so that's not a good sign, but I already know what I think it is. So if we take a look, you'll see that our obstacle spawn timer divide by 0 exception. So what's going on here? Well, if we go to our game manager and go to our inspector, you'll see that we don't have anything in our pick upable scene. So I'm going to click on that and I'm going to add in our coin just like that. And I'm going to hit play and you'll see now, in theory, it should spawn in our coin. Though I'm not seeing a coin. Well, there's one. So we'll run over it. You'll see we have 19 points now. So that's good. You'll notice that our spawn points for coins are really low. So we're going to have to take a look at that and see if maybe our random number generator might not be 0 to 1. So let's take a look and let's see if that's the case. So first things first, I'm going to come in here and I'm going to see, I think randf gives us a very large value. No, it says it's going to be a floating point between 0 and 1 inclusive. So it actually is correct. That should work. So our spawn chance is a 0.3. I think that's probably fine then if that's the case. So now that we have coins, what's next, right? What if we want a row of coins? Because coins are just appearing, right? But they're not like a row of coins or something like that that requires you to move. It's just a singular coin. So what can we do to make it better? Well, what we can do is we can change this to be its own function to or we can change this to be its own function and basically have different methods for us to be able to spawn stuff. So first things first, I'm going to change this to spawning coin. That way it's just better for me for future. But if rand value is this, then we're going to do all of this stuff, right? So we'll just grab all of this, right click. We're just going to select all of this, click on this guy right here, and I'm going to extract method. So we'll click that, and it's going to create a new method. Now, I don't like that it named it new method. So what I'll do is I'll call it spawn coin, and then I'm going to go and hunt down that new method. So it's right here. So we'll just paste that like that. That way it actually, follows some form of consistency, right? Though that being said, we could probably go with a lowercase s and an underscore because it is a, local function right here. So I'll just do that and do a lowercase s. A lowercase s, and then we'll come down here and just do a lowercase s. That way we don't have that naming convention rule mismatch that we're dealing with here. So when we want to spawn a coin formation, first we need to determine what the type is. So I'm going to go int formation type is equal to, and we're going to cast this as an integer, but we're going to do a rand I. So gd.rand I like that. And actually, well, that's fine. We'll adjust it in a second. Modulus 3, and I'll put a semicolon. Now, something that I didn't notice is that this should be brought out of our function because this is determining if we're picking up a coin. So let's just grab all of this, get rid of it, come up here and paste, and then put in 2 brackets like that. So that way we can get back to where we were because we don't want to just always spawn coins, right? So we need this out of here. And then that means we need to get rid of 2 of these. So we'll burn both of those and we'll hit Control Alt Shift P, format that document, and then we should be good to go. Now we could also pass in a pickupable. So you can see here it says pickupable does not exist in current context. That's because if you see, I have the pickupable here. So I'm going to pass in a pickupable. So we'll pass in pickupable, and I'm going to copy this guy here, scroll down, and paste it. That way we can keep our code nice and simple and easy to work with. And something I'm looking at is this int rand here that I caught myself. I don't think I need this. I think I just need this lane right here to spawn a coin. And then from here, I think we need to grab this. My apologies for this, but for some reason, I added an extra rand in there, and I don't think we need that. So I'm not sure what I was thinking there, but we'll come in here and we'll say switch formation type, and we'll say case is 0, and then we'll say if case is 0, it's going to be a standard pickupable object. So I'm just going to do that, paste that bad boy in there. And now we can come in here and say, okay, so if we have a single coin, that's what this is going to be. If we want multiple coins, we can come in and say case 1 colon space and then break, and we'll say int number of coins is equal to parentheses int gd.rand I, and we'll say modulus 7. So you can have up to 7 coins. Well, technically 6. Max 0 to 6 coins. And then we'll just say for int I in length, and our length is just going to be our count that we did. So the number of coins, like that. And then we can come in here and just say pickupable.duplicate, and I think duplicate returns a node. So we should be able to do pickupable 1 is equal to pickupable duplicate as a pickupable, like that. And that should give us a duplicated coin to work with. And then we can basically just say pickupable 1.position is equal to a new vector 3, much like we did before. So you'll see here where we do this guy right here. So we'll just copy that, paste it. Now the big change that we need to do here is with our spawn distance, we need to add on multiplied by 2.0f, and that should handle it. And the reason why is because we want to spawn our coins in a row, right? So we're going to spawn them and then go back 2 units, and then basically go back another 2 units and another 2 units and another 2 units. And that's why we're doing this multiplication, because this value is going to go up. So 0 multiplied by 2 is 0. 1 multiplied by 1, or 1 multiplied by 2 is 2, right? 2 multiplied by 2 is 4. So we're stepping backwards, if that makes sense. And now we should just add our coin. So we can just grab this guy, paste, and actually it probably already is, but we'll double check. We'll try it and see what it does. If it crashes out on us, we know that we don't need to do that, but I'm pretty sure we'll need to do that. And I'm going to do number of coins. And then once that's done, we need to queue free our previous coin because we don't actually need our original coin. We'll say pickupable dot queue free, like that. Now we have 2 different things. So coins in a straight line. And now finally, how do we do it as a diagonal coin set? That's actually really easy. So we'll say case is 2, right? So come in here, case 2, colon, break, because it's always good to have a break. And then we'll say int direction is equal to gd.randf is greater than 0.05 f question mark 1 colon -1. And basically all this is doing is that we're getting a random float value from 0 to 1. If it's greater than 0.5, then we can go into the left column. If it's less than 0.5, it will go in the right column. And that's basically how we can determine if it's going to do that. And now we can just say for int I in length. In our case, it's going to be 3 because we're just going to be spawning 3 of those objects just because it's easier to do the 3. And then we'll say more or less what we did up here. So all of this guy, copy it, paste. And the big difference here is just how we choose our open lane. So I'm going to hit enter and then just say int index is equal to mathf dot posmod, which posmod basically performs a modulus operation. And that's really useful for this because it's going to give us the ability to have a negative result. And I'm going to say lane plus I multiplied by direction, comma 3. And it is mad at us. Let's take a look at it. Plus operator cannot be applied to float and int. If we take a look at our direction, it is an integer. We take a look at I is not a float. Oh, lane positions. So it's not lane positions, is it? Instead of lane, it's going to be open lane like that. And that should handle that. And then we'll just change this to index. That way we can spawn our stuff. Now I'm going to format this again. We'll format it so that way everything's nice and formatted. And in theory, that should hopefully work. We'll find out when we get there. Now, we are adding these guys, so we do need to queue free our pickupable like we did before. And in theory, this should just work. So let's head back to our game and let's see what happens. So we'll hit play and it fails to build. So that's not good. Top level statement must provide namespace and declaration. So that means that we have one extra guy there. So let's get rid of that. And then let's reformat. So somehow I must have added an extra to our spawn. Let's double check, make sure that this actually works, because right here we're going to have a problem. This is adding a child to our obstacle container. I don't think we want to do this anymore. No, we don't. So we can just burn that right there and save that. And that should be okay. So now let's hit play. Let's see what it does. Now we have a row of 3. Perfect. We have a single one, another single one, a row of 3 like that. Perfect. Perfect. A row of 3 like that, and a row of them in a lane. Perfect. That's exactly what we wanted. So awesome. Now we have the ability to spawn coins, get score, and do the whole 9 yards. So now the question is, awesome, right? We have everything that we could possibly ever want in our little game, right? So how can we handle the death state, right? What happens when a user dies? How do they die? How do we handle that? Well, the way a player dies is by getting pushed off the back, right? So in order to handle dying, we basically need to determine when the player gets knocked off the back here, what happens. So what we'll do is we'll basically add in a plane to detect that. So we'll right click, add a child node. We're going to add in an area 3D, and we'll right click and add in a collision node. Now, the cool part about collision shapes is they have lots of different shapes. Now, you could come in here and place a box back here or something like that. But one of the really cool things is Godot has this thing called a world boundary shape. And a world boundary shape allows us to extend a forever boundary. So you can see how it only shows like this little box here. This actually extends into infinity. So if your player ever falls through the world or anything like that, you could have this and it will detect it and allow us to kill off the player. So I'm going to put this guy back here, something like this, and I'll pull this down, you know, something here-ish. And then we're going to call this the kill plane like that. And we'll go ahead and go node on area entered. We're going to copy that and connect it to our game manager. And then we'll need to reopen up Visual Studio Code and go public void paste parentheses. And then this is going to pass back an area object. So we need to go area 3D area like that. And when this happens, we can have the game manager broadcast an event. You know, much like how we did before with the score, we can come in here and broadcast an event to handle when a player dies. And we can also come in here and do one for when the player is respawned, right? Because if you're going to die, you're going to need to be able to respawn. So we'll type game over event handler, and then we'll come in here and we'll also do start game event handler. And I'm going to go and get rid of the score for the start game, because we know that when we start the game, right, we're not going to have a score to broadcast. And the reason why game over has a score that it's broadcasting is because we want to broadcast and say, hey, this was the final score that this person got, right? That way we can catch it later, populate leaderboards, maybe show it on a screen, right? Things like that. So I'm going to change the name here to start game, not star game event handler. That way we have a proper thing. Now I'm going to also hit enter just to give ourselves a little bit of extra padding here so we can break up our code. And now we'll come down here and we'll basically just broadcast our event. So we'll say emit signal, signal name dot game over, comma, and then we'll pass in our score like that. That'll basically just broadcast out that event. So that can be very useful because that means if the player crosses that, we can tell the player they're dead, right? If we want to go into the UI and show up a UI element, we can listen for the signal and use it. Awesome. And now what we can do is we can create a UI scene that's going to show that the game is over. So we'll right click, add a child node. We're going to add a control node like this, and we'll make it about, I don't know, about yay big, give or take. We're going to drop it into the center. We'll right click, add in a panel like so. We'll also make that full rect. So let's do that really quick. And then we'll come in here, add in a child node, and we're going to add in a VBox container. We'll make that also full rect, and then we'll right click our VBox container, add in a child node, and we're going to add in a label like that, and we'll just call this game over like that, and we're going to make that a center alignment. Now, once we have this, we can right click, add in a child node. Let's add in a second label. Let's call this the game over label and the score label like that. And we'll type score, or I guess maybe final score. I think that's probably like a better term for it. And then we'll make it center aligned. That way, up, vertical, horizontal, center aligned like that. That way it shows your final score. Now we're also going to want a button, and we're going to make this start over, or perhaps play again. Maybe play again would be a better choice here. And we will make this the play again button like that. Now you'll notice that this is all the way up here and I want it down here. So what we can do is we can create a control node here and we can drop it in between our play again and our rest of our stuff. And then we can come in here into layout and change our custom mini size to, basically pull this out to wherever we want. So something like maybe 100, maybe 150 or 160. 190 is too much, so let's go with 180. Actually, I just learned you can hit up and down and it'll increment. So that's new to me. So that's a really cool feature. So 177 looks like it's about right. I do wish they had the ability to do horizontal container scaling expand. That would be nice because then it would actually expand properly. Because horizontals, I kind of want it to expand for the entire space of it, but it doesn't seem like it wants to. But that's okay. So you can see right here, this is what we have. And then we could call this the game over VBox like that. And then we can call this game over panel like that. I'm going to copy that because I'm going to need that later. And then we can basically just go into our UI manager and then we can come into our game manager here, click on node, and then say, well, it's not going to, and you'll see that it hasn't shown up. So we'll build our project. And once it builds, you'll see we have game over. So we'll double click that on game over. So we'll copy that. We'll go over to our UI manager, or I guess we'll copy this on game manager, game over, and then connect it. Go into our UI manager here, public void, public void, paste, bracket, and then say int score. And then we can basically show our game over panel. So you can see right here, our game over panel is right here. It's going to be hidden because we don't want it to always be shown. So we'll go ahead and show that. So get node, quote, game over panel dot show. And you'll notice that show doesn't come up. So what we can do is we can call this a control node like so to type it properly. And then we can come in here and go dot show. And there you go. Easy enough. And that's going to pop up our game over panel. And now we need to grab our score label. Now we can actually copy our node path by just coming in here and hitting Shift Control C, or by clicking copy node path. And then we could say get node, and it's going to be a type label, and then we'll pass in our path, something like that. Now you can see it gives us our UI manager. We don't need that. We can just get rid of that and then say dot text is equal to $quote score colon bracket bracket score, like that. Simple enough. And that will basically show our score. And that's pretty much all we need to do for our UI manager to work. And now we can come in here and handle if we want to play the game again, right? Because if we die, we want to play the game again. So how can we handle that? Well, we can double click on our on play button down here on the signal and then connect it to our UI manager. So we'll Control A, copy, paste in here. We'll say public void, paste, parentheses, and we'll go from there. Now, what's the best way to make our game playable again? Well, first we'll need to reset our player position, and we're going to need to reset our score, right? We'll need to hide elements and things like that, and then basically reset everything. So what's the best way to handle that? Well, if we make the UI manager broadcast an event, that would be a great way to approach it, right? Because it's going to decouple our code from each other. So we can come in here and go signal, public delegate, void, and we can pass in start game event handler like that. And that will give us an event to work with. Now, something that you'll notice is I'm doing start game, not reset game or anything like that. So why is that? Well, when the player starts their game, we're going to want to give them the ability to click and start their game, right? So we'll just call it start game. That way we can have one event to handle two separate things. And that kind of helps consolidate our code a little bit. And when you click this button, we'll just emit that signal. So we'll type emit signal, signal name dot start game, and we don't have any arguments, so that should just work for us. Now we can come back here, hit save, build it, and then you'll see when I hide my game over, I click on my UI manager, I have start game. Now, who needs to know that I'm starting my game? Well, the game manager for one, and the player. But we don't want to couple our UI manager to our player. We want to couple our player to our game manager, right? Think of it kind of like a tree, right? You don't want anything to cross between nodes because it can cause a lot of problems. So you always want to try to work your way up to the shortest route path when you're doing signal management. It just helps keep things clean. So I'm going to hook my UI manager to my game manager, and I'll come in here and I'll say public void on UI manager start game, and I'll come all the way up here and I will do a start game event handler, and I'll rebroadcast that. And because I'm rebroadcasting that, anybody that listens to that event can react to that event. And like I said, the reason why I'm doing that is because I don't want my code to cross boundaries. I don't want signals to cross boundaries between different parts of my project, if that makes sense. And from here, I can set my score equal to 0, like that. And then I can come in here, go into my player, right, this portion, and listen to that event. So if I come up to the game manager, I do start game, and I hook it up to my player, like so. I will connect it. I'll come down to my player, and we'll hook that up. So public void. And then we can do different things here to reset our stuff. For instance, resetting our location. So our player's position is 0, 0, 0. So we'll just say position is equal to a new vector 3, 000, and that's going to reset where our player is located. We're also going to want to basically make sure that they're not dead. Now, we still haven't really handled, right? We're kind of recursing down, but we still haven't really handled when a player dies either. So we do need to handle that. So while we're in here, let's go in here and let's also hook up game over to our player as well. And now you might be wondering, okay, so how can we handle if a game over happens? Well, you can see here, we have all of this code here that gets ran, right? And basically we can come in here and create a Boolean to handle that, right? Is the player alive? Or we could do state management, and both of them are valid ways to do things. And really, this game is simple enough that having a state management system might not be worth it. It might be worth it, it depends. But in our case, I'm just gonna say bool dead, like so. And I'm wondering why I didn't put private here. Normally I declare these, but my brain has not been working apparently. So I'm going to change those all to private where they should be. You should always call them out. It's just good practice. And we'll come down here and just say, if not dead, then do all of this. Simple enough. However, if you are dead, then don't do anything. So now the player loses all control over their player if they're dead. They just can't do anything. And on game manager game over, dead is equal to true. Simple enough. And if they start the game, then dead is equal to false. Also simple enough, right? And that's basically all we need to do on our player end to handle if they die. It's really that simple. Now, when we reset our state, we're going to need to go into our game manager and set some stuff up. So you can see when we hit this, we emit a game over, right? We kill the player's now dead. And in theory, that should work. So let's test it out. Let's see what happens. If we hit play, first things first, we compile. Second things second, we have a slight issue where there is a box existing in my screen, but let's see what happens if we die. So I'm going to let myself fall. Well, nothing. So that's not a good sign, but first things first, let's take a look at what is covering this panel here. That's because the game over VBox got hidden, not the game over panel. That's my fault, although we probably should make it so that the UI manager on game start, so you can see when the play again. But this does highlight a possible issue, right? When the game starts, we kind of want to hide panels and things like that. So what we can do is listen to our game manager when the start game happens. So let's click on that and let's go to our UI manager, Command A, Control C, Control V, and connect it. And then we'll just say public void on start game. Now we can set up some of our UI events, right? So we can come in here, copy our node path, get node, make that into a control node, and then paste. And then we could basically just pull this out right here. And then we can just say dot hide, like that. And that will hide that panel. Just in case it shows for some reason, we could just hide it. And that way things get handled for that. The other thing that didn't happen is our kill plane didn't do anything. So if we take a look, we have an error, native call, non-native string name interop, call from some random thing is broken, right? So what does this mean? Because that's a lot of words and it means nothing. Well, it says here, error calling signal from signal G, and you can't really read it, unfortunately, because Godot doesn't have wrapping on the window, which is a major unfortunate circumstance here. But from what I can tell is it's mad because the game manager at 158, if you see down on the third or fourth line on the stack trace, it says 158 on kill plane, enter Godot area 3D. So if we take a look at that, game manager on kill plane, emit signal, game over, signal name, score. So it's unhappy with this. It says that it's unable, it's saying it can't execute this. So the question is why? So let's take a look at our game over signal. It is set up correctly. It's always good just to double check to make sure the error comes up again. And yes, it does. So why? On area entered, kill plane, area enter, area 3D. So that does fire off. Let me open up a new text file here. Let's paste the error. Error calling signal to callable character body 3D on game manager method not found. So my character body 3D is not picking up my signal. So the question is, why not? So let's see. What function is it calling? On game manager game over. Let's copy that really quick. Let's go to our player. It's because it passes in a string. So it passes in an integer. It passes in score. That's why. That would be my guesstimate is why it's broken. So if we flip this back, let's try that again. How much you want to bet that's going to fix our problem? So we'll let our character die. And there we go. And then if we click play again, we start over. Well, kind of. The thing doesn't get fully reset. You'll notice that stuff was spawned right off the bat. So that's a problem. That's going to be a bug we're going to have to solve. But at least we have something going. Let's hit stop and let's solve that issue really quick. So if we come in here, let's go to our game manager, and on game over, when we emit that score right here, let's just go into get node 3D quote. And I believe we had a obstacle container here. So let's go like this, get the name, paste it, .get children. And we're going to pull back the children. Now this is going to give us an array of nodes. You can see right there. So we can just say array of type node. Children is equal to that. And then we can just go for each var item in children. Then we can item.queue free. And that'll just eliminate those guys from the stack, so that way we don't have to deal with them anymore. And now we basically have a very basic game on our hands, right? You can fall, you can die, but you'll notice that, and we can restart. But you'll notice that A, when we hit play, we start immediately, so we can solve that really quick. And B, the game never really gets any harder, right? You just kind of run forward until you go forever. So how can we make difficulty, and how can we do it so that way when we start the game, it doesn't immediately start? Well, to do the second one first, let's come in here and let's basically duplicate this panel. So we'll duplicate our game over panel. We'll make that one on really quick. If we come in here, we change this to endless runner tutorial. We get rid of our final score label because we don't need that. And we actually can come in here, actually, now that I'm thinking about it, and say left for left lane. And there we go. We could just add in some words here to help, guide the player on how to play. And then we can make this a bit smaller. So 120, probably somewhere in there, or maybe we'll go with 90, 80, 87. I don't know. There we go. And that's perfect. So that gives us some kind of a dictation here. If we go into play again, we can just change this to play, and we can change our game over to, or our endless runner tutorial. We could actually change this. If we go into themes, theme overrides, we can come in here and change the font size up to something pretty large, and we should be able to, and that will just give us a little bit of variation here. So the user sees that this is the title of our box. Now you could also do the same thing for game over, but that's up to you guys. Now I'm going to change this to start game panel, and I'll go into my UI manager here. So we'll click on this and we'll come in here. And when we click the play again button down and the game starts, we can come in here and grab our start game panel. Let's rename it, copy, and do that. And now we can just hit play and you'll see, awesome. But our game is running and our player can actually be moved, right? So what's going on here? Well, we need to come in here and disable the ability to spawn stuff. And we need to disable the ability to move when that happens. So first things first, to disable the ability to move, if we just go into our player and we say dead is equal to true, and we just start that off as true, that'll handle that problem immediately. So that won't be a problem. But to stop stuff from spawning, if we go to our game manager, you'll notice up here, we're starting our timers immediately. So if we get rid of that, that will stop that problem. And then we can come down here and say on start game, start our timers. And then when the player dies, we can also stop our timers as well. And that should stop a small issue that we would have ran into if we had let this continued. And now you'll see if we hit play, well, we still spawn, so that's not a good sign. Let's see if our labels here are set to auto start. They are. Our little timers here are set to auto start. So we'll get rid of that and then we'll try one more time. Now you'll see nothing is happening. When you click play, the game starts. When you die, game over, score of 38, everything is deleted. We hit play and then everything resets. Simple enough. Now we might be getting too many coins, so we might want to adjust the logic on that. But at least it is working. So awesome. So now that all of that is working, the question is, how can we adjust the difficulty of the game? Because obviously the game's not getting any more difficult for us. So when it comes to difficulty, we'll ratchet up the difficulty as the user gets score. So I'm going to actually come into here and I'll make the difficulty go up in this section here. So what we'll do is we'll scroll up to the top and we'll do what's called a speed multiplier. So public float speed multiplier. And I'm going to make that equal to 0.2f, just so that way we have some kind of value here. Now I'm also going to export that value. So there we go. We'll export that out and then we'll scroll down here. And when we update our score, we'll just say speed multiplier plus equals 0.1f. And that'll give us a basically step up in speed. And then that means every second about we will be getting a ratchet up in speed. Now, how are we going to get it so that people can actually handle that speed change? Well, if we take a look at our obstacle, and you can see here, we're doing a speed multiplied by float delta. So we have a public float speed, so we can actually change that to make it faster, if that makes sense. So we'll come in here and we'll go into our spawn code and we're going to change the speed of our objects based off of what our speed multiplier is. So if we come in here, we can do pick, actually I'll start from the bottom because it'll just be easier. So we'll come in here, we'll do pick upable 1 dot speed is equal to pick upable 1 dot speed plus pick upable 1 dot speed plus equals pick upable 1 dot speed multiplied by speed multiplier. And then I could basically just copy this, go in here, paste, come in here, paste, but change this from pick upable 1 to just pick upable. And then we can grab this one more time, go to our obstacle code and handle that. So paste, obstacle instance, like that. We'll copy this. And I think this is actually current obstacle, so we'll still need to change it anyway. So paste, current obstacle, that. We'll grab this bit of code Oh, I guess this one's obstacle instance as well. So that's totally fine. So paste obstacle instance. There we go. And that should do it. So now that should allow us to have some basic change in our speed. So if we change our speed multiplier to something ridiculous, because we're going to want to see this go quick, right? So let's head over to our game manager and let's actually, I think what I'm going to do is I'm going to go into my game manager really quick and I'm going to come in here and instead of just exporting this out, we'll export out a second one and we'll say speed increase multiplier as well. And we'll export that out as well. So now we have a starting point and then we have an ending point. How much are we going to ratchet up the tension? How fast are we going to make this game go? So we'll do that. And then of course, if we wanted to, we could come up with a max speed as well, but I'll leave that for you guys to figure out. So I'm going to come in here, build this, and you should see a speed increase multiplier and a pickup speed multiplier as well. So I can set this to something like 0 and then set this to something like 1. And in theory, if we take a look at our code here, right here, you can see we're still incrementing by 1F. So we'll say speed increase multiplier for our on player score. And then we can hit play and it should, if we hit play, we get 1, 2, see how everything's starting to speed up? Much faster. Now we're going probably too fast for the Godot code, but you can see that it's at least working. Ooh, yeah, we can definitely go through objects because the collision speed on Godot is not designed to handle this. But you can see that that's how we can make our speed get up there, right? And really make the game quick. So there we go. Now, something that you'll notice is when we hit play, some of the objects are moving way too slow. That's not because it's going to be an issue in the actual production, because we're going to do something like, 0.1 and that's it, right? So in reality, you're not going to see it. But just so you know that there is a slight issue with that, where sometimes obstacles are going to be moving slightly faster. You can see how everything's starting to speed up a little bit, starting to get a little bit harder. So that's how we can handle this. Nice and simple. Awesome. So now the question is, okay, so we've got game over state. So if I kill myself, we have a game over state. We have a score. We have difficulty. We have the ability to pick up objects. Really, at this point, what's left? And at this point, we basically have a game. But what happens if we want to have a leaderboard? So in order to do a leaderboard, we need to create a UI element for that. So let's go into 2D here and let's build out this UI element. I'm going to hide these guys and we're going to put it over here on the right. That way we can actually have our leaderboard right here. So I'm going to right click, add new child node. I'm going to add in a control node and I'm going to drag that control node, providing I can actually grab it. There we go. And bring it right over here. We're going to make it about, about this big. And I'm going to call this leaderboard. We're going to right click, add new child node. We're going to add a VBox container. We're going to make that full rect like so. And I'm going to drag that down just a tiny bit like that. I'm going to right click, add another child node. We're going to add in a rich text label. We'll make that upper center like that. And we'll pull this down. Now I probably should also add a panel in here to throw that around the back, and we'll drag that up so it's behind our stuff. We'll click on our rich text label and we'll just call it leaderboard. And we'll do bracket B, which will make it BB code bold. And I believe we can also do center as well, like that, or maybe not. So we might have to actually just do right here under horizontal alignment, we can just do center like that. And now if we take a look at our VBox container, you can see it is about the right size. So that should work. And now all we have to do is basically display the scores on that leaderboard when a person is completed and hide it when we are in gameplay and show it, of course, when we are not. So we'll hit the script icon. We'll come down here, come in here and say get node. Control leaderboard, and we're going to type show like that. We'll copy that, and on play again, we will, and on start game, we're going to hide that. And there we go. And that'll basically show and hide our leaderboard when the game is over. And now we need to figure out a way to handle how we are going to show our leaderboard, right? How we're going to populate that leaderboard. And we'll come up here and basically discuss this a little bit. So a leaderboard needs to have a list of scores, right? So first things first, a list of scores, totally fine. So we can do a private list of int scores, and we'll make that equal to a new list int of high scores like that. And then we kind of need a way to maximize the amount of, we need a way to limit the number of scores in our leaderboard, because you can't have unlimited, because if you have unlimited, you're just going to run out of storage space. You're going to run out of UI space, things like that. So it was a good idea to have some kind of limit. So I'm going to make an exported variable for that. So I'll say export public int. We'll make that equal to 10. And then whenever a game over happens, we basically need to add that score to a leaderboard. So on game manager game over, we need to show our panels. And then we need to do high scores dot add, and we need to add our score like that. And that's going to add our score to our high score list. And then from there, we can go high scores is equal to high scores dot order by descending s equal pointer s dot to list like that. And that basically just orders all of our list by descending. So it's going to automatically handle all of our ints, make them descending, so that way it shows the highest score first. And then we'll go if our high scores dot count is greater than our max leaderboard entries, then we're going to trim that list. So we'll go high scores dot remove range max leaderboard entries high score dot count minus max leaderboard entries. And that should trim out the stuff that we don't need. So it just kind of resizes the list so that it's the proper size for what we need it to be. And then we need to update our leaderboard display. So first things first, we need to get all of our children inside that leaderboard and then eliminate them because they're not needed. So for each var item in get node leaderboard, and I believe it's a capital L if I remember correctly, dot get children. And we're not going to just want to get our children, we'll want to get the VBox containers children. So we'll do leaderboard slash VBox container, and then we'll queue free it. That will eliminate everything from that list. And then we'll add our new entry. So for I in highscores.count, like that, then we'll basically say var entry is equal to a new rich text label. And the reason why I'm choosing a rich text label is because whoever has a high score should be bolded, right? So we want to have that flexibility to work with it and make it bolded. So that's the reason why we're doing that. Then we'll turn on BB code because that's going to allow us to do the bolding if we need it. And then we're going to say entry.fit content is equal to true. Hopefully this will adjust the size to be proper. Maybe not. We might have to go to a custom mini size, but we'll try this for right now. And then if I is equal to 0, then we know that that's the first element. So entry.text is equal to $ quote bracket bracket B I plus 1 period high scores bracket bracket I, and that will make a bolded version of our text here. And if not, so we'll say else, if that's not the first entry, then we can basically do the exact same thing just without B, and we should be good to go. So then we can get our leaderboard, which really, arguably, we should do something like this. So control leaderboard is equal to, we'll just grab this, paste like that, and then we can just grab leaderboard because we're actually selecting this multiple times so far. So it's probably just a good idea to do that. It makes it a little bit easier for us to work with. So leaderboard dot add child, and we'll need to put this inside of here, leaderboard dot add child entry like that, and that will allow us to have our score. So now if we hit play, let's see what happens. So you'll see when we hit play, we have our leaderboard, we hit play, it goes away, perfect. We go underneath this guy, pick up a few things, and then fall to our death. Well, it didn't do, well, frankly, anything. So that's not a good sign. Let's see what's going on here. So on Game Manager over, it did show the panel as expected. High scores, add score, high scores order by descending. If count is greater than that, it's not greater than that, unless our max leaderboard entry is 0, which is possible. Let me double check, take a look at our UI manager. What is our max leaderboard entry? 10, so it's not greater than, so that should be fine. For I in item, let's take a look at our UI manager. Leaderboard, it did create a rich text label. My guess is with the score. Yep, it did right there. You can see there's our score, but it didn't give us, it didn't put it underneath our VBox container. So that's because this is doing leaderboard.addChild. So leaderboard.getNode, and we'll pull back the VBox container here. And I believe we're doing it right here. So that's perfect. And then .addChild. So that's pretty much why we had that issue. Let's try that again really quick. We'll make this really quick this time. So we'll do this. We'll die on the first thing. So score of 2, 3, 4, 5. Score of 5. And then if we hit play again, 1. Now we have 33. So we just dominated the previous one. And you can see we have 46. Perfect. That's exactly what we wanted. So that means that our stuff is actually working pretty well here. So now the question is how can we actually save and load our leaderboard? Because you'll notice that if I hit play again and I die, my leaderboard's completely empty, right? So how can we save our data? How can we load it? Now, in order for us to save our game, we're going to need to actually create a function for that. So we'll come down here and we'll say private void save leaderboard like that. And then we'll come in here and we're going to open up a file and save it. So using var file equals file access dot open, save file, and we're going to need to come up with a path. Now it's up to you guys on what path you guys want, but in my case I'm going to go user : high scores quote user : high scores dot save like that. And then we can choose our file mode. So a file mode flags, and we're just going to do write like that. And then we could do try string JSON string equals JSON serializer dot serialize. And we'll pass in our high scores like that. And then we'll just store that string. And basically what this is going to do is it's going to save our leaderboard. Now we have to do the same thing. And basically what this does is it creates a file, it creates a string, and it writes it to it. And the reason why we do that is because it allows us to actually write it in a format that our Windows machines will understand. And that way we can use that data in the future. And I do have a expected catch. So we'll do a catch. And we'll just say exception E. And we'll just say gd.print error error in saving leaderboard, bracket, bracket, e.message. We'll need a capital M, and we'll also need to put a $sign in front of here. And there we go. And now we can do the same thing, but we need to load our data. So in order to load our data, we'll just duplicate this, type load leaderboard. And then file mode is read instead of write. And then instead of doing what we're doing here, we need to get the file as text. So we'll come in here and do file.get as text. And that will pull back a string. So we'll just grab this bit here and paste that in. And then we have a JSON string. So we need to parse that data. So we can use the Godot serializer for that. So we can say var loaded scores is equal to JSON serializer dot deserialize. And we're going to do that as a list of int. And we'll pass in our JSON string. Now this should load back as a list of int. So in theory, we should be able to pull that back and work with it. Now, that being said, we want to do a little bit of error checking. So I'm going to set my high scores here by doing a little bit of checking. So I will say loaded scores question new list int, like that. And you might be wondering, oh, okay, hold on a minute, Mitch. What in the world am I doing here? Well, this checks to see if this is null. And if it is, it just initializes it as a new list just in case. So that way we have a way to handle if it's a null value. If somebody goes in there, they mess it up or something like that, it'll handle that. And then I'll do error in loading leaderboard as well. And then we can grab this bit of code here and paste. And instead of doing loaded scores, we'll just do it as a new list. That way, if anything goes wrong, we just initialize a new list and we're good to go. That way, nothing really can break for us. Now, we need to load our leaderboard on startup. So let's go to our ready and do load leaderboard, just like that. And when we load our leaderboard, we're just loading the values, right? So we need to actually set up our leaderboard. So you can see here, we have this section here, which kind of sets up our leaderboards, right? So what we can do is we can come in here and refactor this. So if we grab this and we control X and we just say populate leaderboard, like that. If we click on this little guy here and we extract this, so there should be an extract to local function, and we extract to method, that should do what I need it to do. Now we're going to rename this method to populate leaderboard, like so. And there we go. In theory, that should do what I need. And then I can take this guy here, bring this up here into my ready, and populate my leaderboard. Now it looks like this passes in a leaderboard object, which is a control node. So what I can do is just grab this control node, copy it, and bring it up here and paste. Now, technically, if we wanted to, we could make that into a class variable, and that might be a little bit better, but I'll leave that to you guys to handle. Now, once we're done with that, we need to save our leaderboard as well. So here's our save leaderboard code. So let's grab that and let's go up to where we're now populating our leaderboard and save our leaderboard. So anytime we complete a game, we save that leaderboard. And now if we head over to our project here, we hit play, in theory, we should have our leaderboard. So you can see we have an error here, but that's totally fine because that's to be expected. We're going to lose right here. We'll get pushed off. 56. We're going to close the game. Going to click it again. And now you can see that it has 56 as our value. So that is how we can save and load our data. And where it got saved out to, if you're curious, is if I click on our Godot project, I go into project, open user data folder, there's going to be a folder section called endless runner C#, at least in my case, because that's what my tutorial is called. And I have a high scores.save. So if I open up Visual Studio Code, I open up my endless runner, I drag this in here, you'll see that it says 56, and that's how we save our data. Now, if I run the game one more time, just to show you guys, if I play the game and I die almost immediately, which it looks like, again, our coins are spawning way more often than they need to, but we can push ourselves back 59, and you'll see that we have 59, and you'll see that our saved game gets updated with 59. So that's basically how you make an endless runner inside of Godot. So at this point, you have a very basic understanding of how to make an endless runner inside of Godot. So if you like this video, go and hit that like button. Hey, you know, if you dislike this video, go and hit that dislike button, because I am here to make content for you guys. This video was a viewer suggested video. So, you know, if you have any suggestions, please let me know in the comments below, or jump on my GitHub, link is in the description, and there should be a project section there for you to be able to suggest projects and suggest ideas. You know, I'm still working on how to integrate WWISE inside of Godot, and I'm also still looking at that Nakama self-hosted tutorial, but that one's been kind of difficult because of how Trafic works, and it's a whole thing, so that one might take a little while. And hey, if you have any questions or comments, please leave them in the comments below, or jump on my Discord, link is in the description for that, and anyone there will be more than happy to help you out. But that is all I have for you guys today, so thank you so much again for watching. I will see you all next time. Thanks.